So as our screen is coming up and getting ready, we are going to have some things to note. We want to make sure we are getting in all missing and late assignments at the end of the trimester as it's quickly approaching. And remember that if you need extra help on any of this, please stop in for RPT on Thursday. With that being said, let's talk about our lesson for today, which is rationalizing radicals. Our objective is to learn how to properly mathematically write radicals so that there's no radicals in the denominator. And we call this mathematically rationalizing. So in order to work with radicals, we do not like to have fractions with radicals in the bottom. So let's take a look at this next slide. We know it as what is called the quotient property of squares. So when we talk about quotient, quotient is another word for fractions. Notice how we have our radical over the large fraction. It can also then be written as the square root of 3 over the square root of 4. Notice that then is really nice. We can take the square root of 4 and simplify it down to 2. We're going to take a look at using this rule to help us do some of our problems here today. In particular, the reason why this rule is helpful is notice that we started off with the square root of 15 over 64. With that being said, we can then write the radical separately into the square root of 15 over the square root of 64. Thinking about the square root of 15 over the square root of 64, I should be able to recognize that the square root of 64 is a nice number, so I can then write that as 8. Since this 15 is one of those numbers that cannot be broken down, my final answer is going to be rad 15 over 8. So let's practice some more. If you need, please pause the video, allow the students to try these, and then see how they match up. Square root of 23 should then get written over the square root of 9. In this particular case, the square root of 23 cannot get broken down, so it stays as is. The square root of 9 is 3, so my final answer would end up being the square root of 23 over 3. Next, I have the negative square root of 17 over the square root of 100. There is no nice radical factors for square root of 17, so it stays as is. Square root of 100 is 10. My final answer ends up being negative rad 17 over 10. We're now going to look at another particular instance, which means that I need to, what happens when my denominator is not one of those nice perfect square numbers that I can take the square root of. Just like fractions, anytime that we want to get rid of something in the denominator, we're going to multiply by the denominator. So we are going to start off with rad 5 over rad 3n. Notice that in this particular portion, we choose to then multiply by rad 3n over rad 3n. We know our multiplication rules, so that would give us rad 15n. Here in particular, when I multiply, I would end up with the square root of 3 times 3 is 9, n times n is n squared. When I take the square root, it just cancels out the radicals and gets me to 3n. If this example was in particularly a little bit confusing, let's walk through a few more examples together. So let's practice. If I have 1 over rad 5 and I would like to rationalize it, I would multiply by the square root of 5 over the square root of 5. Multiplying across the top like I would do with fractions, I would have 1 rad 5, and I would have that over rad 25. Remember, keep in mind the reason why we're multiplying is to get rid of the radical in the bottom. Notice now that I've multiplied, I have a nice number in my denominator, and it would just end up becoming 5. That would be my final answer. Example number 2. I have rad 10 over rad 3. Want to get rid of that denominator, so I'll multiply by my denominator, both top and bottom. I would have rad 30 over rad 9. Notice rad 9 can simplify, so I would have rad 30 over 3. That would end up being my final answer, as rad 30 does not simplify down with nice factors. Our outcomes for today are that we would like to be able to simplify quotients when the radical is a perfect square number, and we would also like to feel comfortable multiplying by the denominator to both the top and the bottom to cancel out radicals. Please take an opportunity to look at the homework that the sub has provided and try problems. Be sure that you do both the front and the back. I will see you when I get back.